The Simpleton's complete numeric proof of Fermat's two squares theorem, which states that every prime of modularity for n plus 1 can be written as the sum of two integers squared. My motto: plain honesty, simple truth, easy understanding, the joy of finding things out for yourself. The Simpleton's mathematical coat of arms: in Euclid we trust, and not the mathematicians. We start with the well-established mathematical fact that the difference of two squares of two adjacent triangular numbers give the cube of the integer that is the difference between the triangular numbers. This then leads us to look at the sum of two adjacent triangular numbers squared, which we find divides by the square of the difference between the two numbers, to give an integer result when the difference is odd and coloured blue, and likewise when the difference is even after the extra step of multiplying by 2 and coloured red together with the output. The results obtained give two quadratic equations, y equals 2x squared minus 2x plus 1, to give 1, 5, 13, 25, 41, 61, etc. for x equals 1 to infinity. The square root equation, since it enables square roots of 4n plus 1 numbers to be obtained by trial and error. And the second equation, y equals 2x all squared plus 1 squared, to give 5, 17, 37, 65, 101, etc. for x equals 1 to infinity, where 5, 13, 17, 37, 41, 61, 101 are 4n plus 1 primes. It is instructive to look at the results if we omit the times 2 multiplying factor for the even differences, and then look at the differences between adjacent results, which starts at 1.5 and increases by 1 at each successive difference, all the way to infinity. Finally, 1. Both quadratic equations are generic equations for infinitely many quadratic equations that fully encompass every possible sum of two squares. In particular, y equals 2x all squared plus 1 squared maps to y equals 2x all squared plus 2n plus 1 all squared, which fulfills every conceivable sum of two squares. 2. The sum of two squares links to the cube of every integer, odd or even, of modularity 4n plus 1 or 4n plus 3. So there are no 4n plus 1 primes dissociated from the sum of two squares number field. Hence, all 4n plus 1 primes behave like every other 4n plus 1 prime, so every one of the infinite number of 4n plus 1 primes is a sum of two squares. 3. In the light of the numeric data, which is indisputable, the statement on which the theorem is based is seen to be speculation founded on stupidity. Reductio ad absurdum.